So we are live. So we'll just wait a few minutes, and we'll let people trickle in here.
Sure.
And yeah.
So, are you from the Northwest, Mark?
I am. Yep. Grew up in Olympia.
Oh, great! I'm a Shelton boy. So,
are you?
Yeah.
My parents are still down on Henderson Inlet.
Oh, fabulous!
Hey, Dan, good to see you. Thanks for joining us tonight. For all the people that are joining us, feel free to leave comments as we go along, and we'll definitely have a Q&A session at the end, but we'll try and stop and address any questions as they come up throughout the presentation. So just leave your comments, and then as we get to sort of spots in the presentation, hopefully Greg will be able to answer those. And if you guys are out there listening, feel free to leave a comment of just where you guys are listening from. If you guys are from the west side or from the east side, it would be fun to see where people are from out there. Nice. Say hi to Amy. Michael, you're just up the road from myself. I'm in Greenwood. Dave's down in Tacoma. Steve's in Renton. Awesome. How many people on are regularly going out and fishing for sea runs? The Michael, the picture that Aaron submitted for the photo contest was awesome. Nice, Dave. I don't go out very often, and when I do, it's very sporadic if I catch anything. Nice. Dan saying that he goes, hasn't been out much recently, but has been doing a bunch of exploring. Well, we'll have to get some time on the water this year and go hunt some down. We'll probably give it, I don't know, maybe another sort of 4 or 5 minutes, and then we'll get started, I think. Did that work for you, Greg?
Sounds good. Yep, sounds good, Mark.
So for those of you that are out there listening, I'll give you guys a little short update on the fundraiser project. I think we should be able to kick things off here probably on the 15th. We have the prizes all. We've got 20 amazing prizes that a lot of companies and people have donated. And we'll be publishing that soon. The GoFundMe is up and hooked up to the Canal Salmon Center, so they'll be able to directly draw from that, which is awesome. Yeah, I've got a big pile of fly fishing gear in my bedroom right now of some pretty cool stuff. So yeah, look for the announcement on the 15th. That should be going out. If there's anybody here that's not from Washington, I apologize. This is really only open to Washington residents, but hopefully most of the people here are and can enjoy and partake in it, and should be a fun time. Another Tacomaite, Jacob, awesome. Jacob, how often are you out fishing for sea runs? All right. Well, I think we should get this going here. So this is my first time live streaming. So forgive me if I'm making any blunders or things aren't working out okay. Let me know in the comments if you're having trouble hearing anything, or any improvements that we can do here. That'd be great. And so I'd love to welcome Greg Shimek. Is that how you pronounce it? I should have asked you before.
Yeah, Shimek. That's close.
And he's currently the executive director of the Coastal Cutthroat Coalition. He's also one of the founders. He's an avid fly fisherman. He is a past president and, if I remember correctly, current president of Puget Sound Fly Fishers Club in Tacoma. And he's currently working as a conservation committee chairman. Greg's conservation work was recognized by the WSCFFI, and he was awarded the Bill McKay Conservation Award for his work with Coastal Cutthroat Coalition. He's also on the board of directors of the Hood Canal Salmon Enhancement Group, and he volunteers along with WDFW, assisting coastal cutthroat research. And he's a Lakewood resident. So with no further ado, Greg, you're up.
Well, thanks very much, Mark. Welcome, everybody. Thanks for tuning in and wanting to hear a little bit about coastal cutthroat science research here in Washington State. Like Mark said, I'm born and bred Washingtonian. I'm from Shelton, and kind of started fishing down then in that particular area back in the 50s. I think, as near as I can recall, I caught my first coastal cutthroat trout in 1958 in Hood Canal, and then primarily spent most of my time fishing down in the deep South Sound around Shelton and Olympia area for coastal cutthroat trout. So I've loved this fish for a long time. The Coastal Cutthroat Coalition, as you'll see, is not really a fishing organization. We're a science organization that's dedicated to the science and research of coastal cutthroat trout, so we can better gain data and manage this particular species. So we're going to get a PowerPoint presentation up to you that's going to kind of cover the coalition, who we are, what we do, how we do it, and then explain some of the science that we found and how that's relevant to cutthroat fishing. Like I said, we're not a fishing organization. We're really a science group that's trying to learn. We can hopefully manage this species long ways into the future. So let's see if we get this presentation up. Is that coming up, Mark?
Not yet.
Okay, hold on. Entire screen. Okay, here. Sharing.
Oh, there you go.
Okay. So now let's get to slideshow. Is that up now?
Yep, I can see it. I don't see it full screen yet, but
So it's full screen here. So
Did you share just the PowerPoint, or did you share your whole screen?
Share. Whoop, let's go back here.
Because I think last time we had to share the your whole screen versus just PowerPoint.
So, share.
Greg, maybe go back and try and share
Yeah.
the screen again instead of the application.
Share screen. Entire screen.
Yep. There we go. Oh, it was there, Greg,
What?
but
What's it?
The window, it was there for a moment, and then I think something you did canceled the share. Try one more time.
Yep. Okay, now then, share screen. Not to get to here. Okay, there's that one. So I'm clicking on the entire screen, Mark, and it just...
So I think all you have to do is if you click the share button at the bottom,
Yep.
Share screen, and then your entire screen, make sure that that is selected in the little black window, and then
Yep.
click share, and then that should do it. And then I can add it to the stream once that's shared.
Okay. I got the little screen up. It's not letting me click the share. What do we do to...
Click on the little preview window, and it should highlight in blue.
Gotcha. Okay. Then hit share. Gotcha.
Cool.
Wow.
And then once you and then once you bring the presentation up, perfect.
Okay. Set up.
There we go. Looks good.
Okay. All right, everybody, we're going to take off, and we're going to go a little bit quick, but if you've got some questions, feel free to answer it. Pop into Mark, and I'll try to answer them first of all. So we're going to talk first of all about the Coastal Cutthroat Coalition, the creation of the coalition itself. Why, who, how, what, and kind of what we've done. So, and again, we're going to kind of blast through some of these slides. Normally, this is a lot longer presentation, but Coastal Cutthroat is a fish that's not really studied very much within Washington State, as well as some of the other bodies of water, especially the anadromous life form, and that's what we study. It's not a commercial fishery, and that's probably a really good thing, because if it was commercially fished, that we'd be in a lot more difficult situation. But it's our native wild trout in Washington, other than steelhead. So it's a fish of importance to an awful lot of people. Economically, it generates now, we think, a little over $2 million in revenue as far as guide trips and materials and on and on and on. So it's a fish that we want to try to keep around for a long time. And so we're dedicated to doing that. So we're kind of going to get into that. So who started the coalition? It was started by this group that you see on the screen right now. Some of you may know Bill Drury, the owner of Peninsula Fly Outfitters, or the Peninsula Outfitters in Paulsbo. Great fly shop guy that's really dedicated to Coastal Cutthroat Trout. James Losey is a fish biologist with WDFW. He's also the director of science and research with the organization. Richard Malzahn runs our website and that type of stuff. Leland Miyawaki, some of you may know Leland. He's a longtime guide in Washington, worked for Orvis. We've got some other directors now as well. And unfortunately, the guy you see to the right over there, it was one of our directors that you'll see, and he just unfortunately passed away from us. And so we really miss him. But this is the group that actually started the coalition up. We have a board of directors. I'm the executive director of that. James Losey is the director of science and research. Mark Dalton has our marketing. Richard Malzahn, like I said, runs the web page. Dwayne Fogergan, I don't know if anybody knows Dwayne or not, but he used to work for Puget Sound Partnership. A scientist and marine biologist, has his own shellfish company down in Totten Inlet. Bill Young, who on the right, who unfortunately just passed away, is a director at large. Ted Parker is a Snohomish aquatic guy in Snohomish County. He's one of our directors as well. We just brought on Keith Robbins, who is going to be our director of finance, so he's new with us as well. Kind of the group that runs it right now. We're a standalone organization. When we started this organization back in 2015, it was really to try to fund a single particular research project that the Department of Fish and Wildlife wanted to be involved in, studying coastal cutthroat trout, but they didn't have the finance. And so they reached out to the group that we just kind of showed and said, is there any way that you could kind of see if we could help finance this project? And so that group took off and took this on as an endeavor, and off we went. And so I'm going to show you kind of how we did that, but it was an impetus from a research request from the Department of Fish and Wildlife. And as you'll see as it goes on, one of the things that was really, really important to us is that if we were going to get involved in finance funding projects, we needed to have a really firm project partner. And you'll see how that progressed. But we reached out to Hood Canal Salmon Enhancement Group as one of the 14 fishery enhancement groups in Washington State, and joined partnership with them in 2017. And so this is our board of directors. That actually, we're a standalone group. We run our own finances. We do all our own work. We work conjunction with biologists from Hood Canal Salmon Enhancement Group because we're in a lot of the same watersheds. But we answer to this board of directors at Hood Canal Salmon Enhancement Group. So when we decide to do a project, or if a project is brought to us for funding, we analyze it among ourselves, look at it, and then we put it before the board of directors of Hood Canal Salmon Enhancement Group to really see if it fits our mission or not, and get their blessing as well. So everything we do is peer reviewed by a whole nother board of directors to make sure that not only is the science correct, but is the financing is correct as well. So we have a very, very good oversight on anybody's funds to get donated to our work. The way when we started this thing is we decided we would reach out to fishing organizations first, so fly clubs. So we went out and targeted fly clubs in Western Washington and spoke to each one of them about the project that we were trying to fund. It was a pit tag study that was ultimately, hopefully, going to give us a population estimate of coastal cutthroat trout in Puget Sound, but it addressed a number of different issues to try to reach that particular goal. But those are some of the people that started it off in the beginning. The Olympic Peninsula chapter in Paulsbo, the Olympia chapter TU in Olympia, North Sound chapter up in Bellingham, all were really, really instrumental in getting funds in the beginning to try to get this off the ground, and then out to other fly clubs that you can see on the bottom, and certainly many others since then. We've really kind of quickly figured out that we weren't going to reach the sum that we were wanting to try to achieve, which was just right around $100,000 for this project, by just kind of speaking to fly clubs. So the second thing that we did is we reached out to the fishing industry. So we went out to guides and fly shops and industry itself. Within the industry, Sage, Patagonia were big contributors in the beginning, and all of a sudden we started getting more funding that way, and so we were able to keep the project online. We got involved with earlier. Maybe some of you have attended the big fundraiser that we have every January, except for the last year, in Seattle. That's run by a fellow by the name of Keith Robbins, who now is on our board of directors. And he's been instrumental in raising the majority of the funding, along with people that attend his fundraiser every year. The majority of the funding that we have put together so far for all of the Coastal Cutthroat Coalition's existence has been through Keith's generous fundraising efforts, and supported by literally hundreds and hundreds of avid coastal cutthroat fishermen. And without them, we wouldn't even be anywhere where we are. Down below, the people on the right-hand side that you can see down here in the corner, my cursor is at, the Gill family in Sumner make some of the most beautiful custom handmade nets that you can imagine, and big supporters of our organization. So the second phase was to reach out to the angling industry. And then the third phase, we reached out to the general public. And we have people now from all walks of life. Georgetown Brewery, Mankey Lumber is a big supporter. They have a lot of Mankey Lumber's timberland is along the waterways in Puget Sound, and they are great stewards of those waterways. The Suquamish tribe, the Squaxin tribe, the Skokomish tribe have all donated and support our efforts. Microsoft has been a matching company for any of their employees. They will match funds donated to us as well. You may, in the picture that you can see, everybody talks about getting a big check, from Publisher's House Publishing or whatever it is. That's one of our first big checks in 2019, literally and figuratively. And the fellow on the right-hand side is Tom Douglas, renowned chef in Seattle, owner of many restaurants, and a huge supporter of the coalition. He puts together a fundraising. He donates many dinners with wine from many of his restaurants, and then he puts on a custom lunch that he cooks for a maximum of 25 people that raises an awful lot of money too. So once we reached out to the general public, we started to generate an awful lot more money. What are we? Well, our mission statement, like I said, is we're dedicated to the science and management of coastal cutthroat trout. So we're not a fishing organization. We all fish, and we love coastal cutthroat trout. And what we're learning certainly helps the fishing community, but hopefully the science that we learn and the data that is gathered will help the fishing community for generations to come. This is, again, like I said, our wild coastal cutthroat. It's one of 14 subspecies of cutthroat in western United States. It's the anadromous life form. There's 4 life forms or life histories of coastal cutthroat trout, and we study primarily, exclusively, really, the anadromous form. So we do that through a lot of different ways. Projects, volunteer work. We're out speaking to education. We speak at high schools. We speak at colleges. We speak to numerous different organizations, whether they are fraternal club organizations or fishing organizations or Audubon Society. It seems like everybody that's interested in conservation understands what we're trying to achieve. And it's not just preservation of the fish itself, it's preservation of the watersheds that these fish they live in as well. So as far as fundraising is concerned, it's donations, events, and we'll talk a little bit later about our current project that we're on that really comes into a grant that we won last year that we're really proud of. We also use social media to reach out. I mean, hopefully some of you have seen us on Instagram and on Facebook, Twitter. We have a website, coastalcutthroatcoalition.com, that you can go to and drop in requests or anything that you want. You can converse with us there. All of our projects are listed there. All of our published papers are listed there as well. So we reach out, we use social media a lot. See, there's some of this is Sea Run Cuts, that is Coastal Cuts, some of the posts that have been on there over the years. We've ran one particular really fun project that we involved the angling community with. Maybe some of you helped with the parasite study that's going on. It's still going on. Go to our coastalcutthroatcoalition.com and you'll see parasite study on there. We're going to touch on it in the presentation. But what we did is we involved anglers catching fish to report back how many argulids or cocopod parasites were on fish or not on fish, and we put their names into a drawing every month, and we pulled a drawing out, and they got shirts and mugs and flies and all sorts of stuff for turning the data in. So social media is used a lot. This is a copy of a headline of one of the papers that's published that's on our website as well. This is just a little quick shot of the argulid study. This is some of the data. You'll see it a little bit later on in more depth. But what the angling community was able to show us is that what months were more cocopods caught and in what geographic areas as well. So that's a really active, fun social media project that we had going on. We're really proud to talk about what we do financially. Like I said, we realized early on that if we were being entrusted with public donations, that had to be a real critical part of our what we do every day. And so that's why we hooked up with Hood Canal Salmon Enhancement Group, because we're part of that 501(c) as well. So, but when you look at science is expensive, ladies and gentlemen, and you don't want to. I don't know how you say that money is important, but money is important to what we do. And so I can see up in the right-hand corner, that particular little tag that you can see right there is $350 a piece that we use in some fish. And the antennas that are used for that down in the lower left-hand corner, about $2,500 a piece. These readers are about $500 a piece. Nets are incredibly expensive for we beach seine for the cutthroat trout. So science is expensive, but one of the things that we're really proud of is that from our inception, all the monies that have been raised, and this is a little bit outdated right now, so some of it's been spent, some of it's unspent. It's really a bigger number now totally because we've achieved more funding since then. But from our inception, all but $275 has been spent exclusively on science. Nobody in the coalition is paid for anything. None of the board of directors are paid for anything. All of our effort and time is all volunteered. We pay for all our own gas in boats. We pay for all of our gas traveling in cars. We pay for all of our overnight stays when we're speaking to organizations throughout the states. The only money that's been spent that has not gone to fund actual science is $275, and we spent that as a gift that we awarded to Keith Robbins for appreciation of raising a little over $100,000 in 4.5 years by himself. So everything else has been spent on science itself. We keep great records of that. We've put on presentations and showed exactly which checks went where. So it's something that we're really, really proud of. So some of the results, we can kind of stop here a little bit, and if anybody has anything that has a question right now about the coalition, of how it was formed up and who it is and why we formed it up, you can fire that off and I'll be happy to answer any of that, or you can want to wait till the end. We can certainly talk about then. So if you've got something you want to shoot to Mark, go ahead and he can let me know what that is. And if not, then we'll go on with some of the results of the science that we've learned. Okay, so Some of these signs we're going to blast by, but just quickly, the fish that we study is the coastal cutthroat trout. So scientifically, its name is Oncorhynchus clarki. It's one of, like I said, 14 subspecies of cutthroat trout in the Northwest. Genetically, it is the oldest. All the other, there's some genetic work being done right now in Utah that may cloud that a little bit, but up until now, right now, all of the other subspecies are offshoots of coastal cutthroat trout. It's the oldest one, and they all genetically share part of their background with that particular fish. There are 4 life histories of this fish. It lives in small little streams exclusively, and those are called resident fish. They live in they all are spawned in tiny little streams, and some stay in our resident. Some leave that stream and go to a bigger stream and stay in that stream, and that life history is called the fluvial life history, which is the kind of the middle fish there. There's an adfluvial fish that leaves those streams and goes into a lake like Lake Washington or Lake Sammamish and grows there and then goes back and spawns. And then the bottom one is the anadromous life form. And it's truly not anadromous in the form of large distance migration like the Pacific salmon do. This fish is a near shore a migrating fish. 25 miles inland is about as far as it ever leaves its natal stream. On the coast, we found them out about 60 miles, but that's the extent of their migration. The graph on the right that you see is a graph that is from the Trask River, Oregon, but it represents work that was done not only in BC but in California and Washington at the same time periods. And what we know just by that graph is we have fewer coastal cutthroat trout now than we used to. That's just a fact. Now, why? That's part of the reason that the coalition was found up. We wanted to try to learn more about why we don't have as many and what we can do to try to get some of those fish back. Thankfully, the Department of Fish and Wildlife in 1999 went to catch and release in the marine environment only. And with what we know now data-wise over the last 5.5, almost 6 years, had they not done that in 1999, it's questionable whether we would have very many cutthroat trout around right now. We thought that it was probably retention fishery in 1999 that drove that precipitous drop-off that started occurring earlier. But when we went to catch and release in 99, as you can see from the graph, there was no measurable increase in populations once they went to catch and release. So it had to be something different than that. And we knew, and now we have some speculation to it. We think because of the science that we've got, we think we have a handle on what may have dropped that thing down where it went down, and the recovery is just very, very slow because of habitat degradation. But we can talk about that just a little bit more. This is the range of coastal cutthroat trout. They are only from the Eel River in Northern California to Southeast Alaska. It's the only place in the world that this fish exists. And the biggest populations are in Puget Sound, parts of BC, and a little bit of in Southeast Alaska. The rest of the areas are very smaller, or much smaller populations.
Greg, I've got one quick question, if you don't mind.
Sure.
So David asked, is there a specific desired goal that the coalition is working towards? Population size increase or expansion of habitat?
So the ultimate goal, our ultimate goal is to try to determine a population of cutthroat trout within greater Puget Sound. That's the ultimate goal. So, they're the only fish that, at least in the marine environment, the only regulation on them is catch and release. You can catch them 12 months of the year, fish for them 12 months of the year, and so we don't really know how much fishing impacts, how much habitat impacts, how much pollution may impact the total population. So until we get an estimate of population, it's really hard for the department to manage that in any meaningful way. So our ultimate goal is to try to determine a population base within Puget Sound so that we can determine best fisheries managements for that. Did that answer his question?
Yeah, I think that was great. Thanks.
Okay. So this is just kind of the study area that we represent where we're going to work. So we're going to talk about a few different things. We're going to talk about spawn timing. In looking for this population basis, how do we figure out how many there are? Well, one of the ways to do that in kind of in fish science is to try to figure out, you know, how many fish it takes to make a spawning red. So when they spawn and they dig their red, just like any fish does, how many fish does that take? Is it just two? Is it a male and a female? Is it a male and or a female and multiple males? So there's ways that you try to study that. First of all, you have to figure out when they spawn. And there's speculations of when they spawned, and that's what's in the books now. But we have been walking some streams. We is usually termed, a term usually used. The department and the coalition and others have been walking certain research streams for the past 16 years now, 17 years. So we've got some real hard data, and we'll show you that in just a little bit. So you can use fish per red to try to get a population estimate, and so that's part of it. So while we were doing that, then we also spun off and found out much more information that we're going to share with you. But so the study area that was originally done was in the Deep South Sound, and it was done primarily on 3 streams. So McLean Creek, which feeds Eld Inlet, Kennedy Creek, which feeds Totten Inlet, and Skookum Creek, which feeds Little Skookum Inlet. Since then, now we've expanded that out, but this is where the original study work was done. So you'll see these colors through different presentations. The black dots that you see, those are spawning areas in those streams. So you can see that the spawning length is kind of the same in most of those streams. These streams are very, very close together. They're about the same type of gradient. And then you can see out these squares that you can see, these are areas where we beach seine. There's 6 of those areas now. This is when it first kind of started out. But these colors are going to become important as well. This green, this blue, and this red. So the first thing that we wanted to do when we got this study going is that we wanted to find out if there was genetic diversity between the populations in these streams. Now there's other streams that come in. Goldboro Stream comes in Shelton, right in here. Mill Creek comes in here. Elson Creek is another tiny little stream that comes into Skookum Inlet right in here. Snyder Creek comes in right into this area as well. So there's numerous different streams. But what we did is we went into these streams and we took genetic samples out of those streams. And we got juvenile fish. So these cutthroat, when they're spawned, they stay in the fresh water for 2 years. Generally, they stay in the water for 2 years. The fresh water, they grow to be about 6 inches long, 7 inches maybe, before they move out into the marine and water, if they in fact do that. Some do. Some choose to stay in the fresh water and just become fluvial fish. They all have the ability to go into the salt water if it's not blocked by some form, but not all of them do. And I think that's a life preservation thing, that some stay in the salt water, some stay in the fresh. They transit back and forth. They can spawn multiple times, of course, just like steelhead. But what we did is take these samples out of these streams, and then we gave the samples to the geneticists. And as you'll see in just a little bit, what we found is that different than the 5 Pacific salmon species, which genetically are really a single genome, if you will, these fish are genetically distinct between stream to stream to stream. So they're all Oncorhynchus clarki, coastal cutthroat trout, but genetically they are distinct between these 2 streams, and spawning wise, they will not go into each other's streams to spawn. Now, that's not to say there isn't some stream switching if a stream becomes unfertile for whatever reason. If it loses a population, it can over time be repopulated by one group of fish from somewhere. But as long as there is a spawning population in these streams, they don't share each other's streams. Now, they will go into each other's streams other times of the year for numerous reasons. We think for thermal cooling down, for possible parasite shedding. There's a lot of different things. But during spawning, they're very, very loyal to their stream. So a lot of different ways that we do some of this work. This is just some of the just regular type normal fish science. So, tagging with pit tags, which are here, tagging with floy tags, which are here, jaw tags, which are here. This is very important in what we've learned about some of their behavioral characteristics. Of course, we can age fish with their scales, and we can also tell whether they've spawned or not. Genetics through fin clipping, of course. So let's look at spawn timing quickly. This can get a little bit geeky if you want. This is just showing what a pit tag looks like, or what a pit looks like when they spawn. Just much, much smaller than steelhead and, of course, salmon. So a big red would be probably about the size of a basketball. Normal reds are probably about the size of a cantaloupe. But what I want to show quickly here is that, so a couple of different things. On the left is the scale. This is red counts in what we call Skookum Creek. It is a creek down by Shelton. And you can see that an average is around 100 reds per year. Okay, some years more, some years less, but there's about an average in that stream of about 100 reds per year. And then we'll bring that up a little bit later. But what you can see over on the right-hand side is that the spawning in those streams prior to this study work was always thought that they spawned somewhere between December and February, maybe March at the latest. And that was really done more anecdotally because cutthroat were in the streams during those months, and you can physically see them when the salmon were in there. So the assumption was that they were actually spawning at the same time. But what we know is that physiologically, these fish are not as big as salmon or steelhead, and so they don't spawn in those same rivers. They spawn in tributaries to those rivers or in some of the tiny little small streams like chum salmon inhabit, but much higher up in the stream where the water and actual gravel is much, much smaller and the flow is much less. And so we know now, just kind of quickly going through this, the spawning cycle for cutthroat trout is much, much more prolonged than we thought. It generally starts in the latter part of January, first part of February, but it's protracted as long as the middle of June. And that's really, really new science. That's been published, peer-reviewed, and people are amazed that it goes that long. And so it's interesting that year by year, it may peak in February, like here. It may peak as late as March. It may be here more towards the end of May. Here it may be again March in this area. But within that, you can see there's peaks and there's valleys, and this was really hard for us to understand for a while. But what we decided to do was, what would drive that? Why would some months produce more than others? So we went back and we also studied flow of these streams at the same time. And so we put a chart over, and so the blue is water flow, and the red is spawning reds counted at the same time. And so what you can see is that if you have high water flows, like in 2012 here, if you have high water flows, we have very low red counts. 2013 on the converse, you can see a really low water flow area here, and you have much higher red counts. And again, we think this is just due to nothing more than the physiologic size of the fish. They just can't stand high water flows. They need enough water to move their gravel, but too much water moves too much gravel, and of course they can't build the red that way. So this is really new science, and this will be in books from now on. That spawn timing is much longer than we thought. So for anglers, so you folks that are watching tonight, what's this mean? Well, if you were setting management of streams to open a stream fishing season, and you were pretty sure that fish were done spawning in March, then if you opened fishing in May, you wouldn't have any spawning fish around, and the fish would already be out of the reds and be free swimming. But what we know now is if you open streams for fishing in the end of May, like we do in Washington, and it happens to be a stream that has retention of 2 fish over 14 inches, then you very likely could be catching and killing spawning cutthroat trout. And also, if you're wandering around wading streams in late May, early June, you certainly still be walking over spawning spawn reds and dislodging eggs as well. So there's a real ramification of learning about the fact that these fish spawn much later. Again, just quick slide that just shows higher water flows, lower red counts. And this red count thing is important because that's how we're going to try to get to the abundance of fish in Puget Sound at one point in time. So let's look quickly at marine movement. We know they travel more in the summer than they do at any other time. The rest of the time, they're very close to their natal beach. So we'll go back to this again. So we know that these fish are genetically distinct within these streams. So the next part of the study was let's go out in the marine environment and we'll catch fish in the marine environment, hook and line wise, and also beach seine wise, and we'll take genetic off of these fish, and then we'll compare those genetics to the freshwater genetics, and we'll find out which streams these fish came from. Okay. So again, it's a small sample. This is an older slide, and so the numbers are really, really high. They've come down some now that we've been able to do this for numerous years, but it's still shocking. So this just goes to show you conservation-wise why streams really need to be protected, why we need to be concerned about water quality in streams throughout Puget Sound, whether they are in downtown Seattle, coming in through gulches, whether they're in Snohomish County, whether they're coming off in the Paulsbo area, whether it's Hood Canal, wherever it is. These tiny little small streams that seem so innocuous, they all have cutthroat populations in them. Small, some, others bigger than others, some surprising. So let's just look at what we've seen. So what we found is that Skookum Creek in the green, when we went out and took the samples, and you'll see this, so Skookum Creek is responsible for 77% of all the fish in that initial study that we caught. Were all from one stream. McLean caught the next, but it was only 17%. Kennedy Creek only had 2% of the fish we caught, and then 3% from other streams that we hadn't sampled. So what we know is that there's mixed stock fishery in the Deep South Sound, but Skookum Creek's disproportionately really, really high. So one of the things about Skookum Creek is when you saw a previous slide, if we average 100 reds in that stream, and let's just say, and we're still working on this total of fish in the stream per red count, and we do that with pit tagging, and you'll see that in just a second. But if there's 100 reds in there and it's 2 fish per red, that's only 200 adult fish that populate Skookum Creek, and it represents 77% of the fish that were caught in the Deep South Sound. That's how important that particular stream is. The other question then is, of course, is how about Kennedy Creek? How about McLean Creek? Why don't they produce? So that's some of the stuff that we're trying to figure out. So again, and these are just months that we catch different fish when we're beach seining. When do we catch the bigger fish? Generally in the winter. You can see that November, December, January, February time, those fish are generally really feeding heavily to get ready for their spawn time in February, March, April, May, June, that period. So one of the things that we did during this initial study when we found that these fish were doing what they were doing, and we wanted to know that we knew where these fish were coming from, but what was strange was we were finding them in the same areas all the time. And this particular slide you can see right here, this was our initial tagging process of a characteristic that's now being called high sight fidelity. So these are little elastomer jaw tags. This is put in with a syringe. You put a different color in every month that you catch these fish. So when we would go out to those sites that we showed you earlier, the little black boxes, and we would beach seine those sites, what we found is these fish will populate a particular beach when they leave the fresh water. So when they're 2 years old and they leave the fresh water, they will populate a particular beach and they'll live there their whole life, except when they leave in the summer to go out and travel around for whatever reason. But they'll come back to that beach in about August and get ready to start building up before they head up and just spawn again in that February, March period. That they come back and they stay on the same beach. And some of these fish that we've caught 8 and 9 times. They had so many tags in them, they looked like a Christmas tree. Next, and this is just kind of showing how that works. So if you look at this quickly, we'll go through it because I know we're running out of time and you guys need to ask some questions. But so here's a fish that was caught in November on a particular beach. It was caught on the same beach in December. And then we didn't see it again until April. So, but what we know is that in March, we found it up in the spawning area because it had a tag in it, and it went over an antenna in the tag, so it told us that it was up there in March. And then, of course, it left, and it came back onto the same beach that it was caught on. So here's Totten Inlet Beach. So it left. It was born in Skookum Creek. It left its natal area of Skookum Inlet. It lives over in Totten Inlet. It travels around, but it keeps coming back here till it's time to spawn. Then it goes back and it spawns. Then it came back to that same beach again in April, and then it spawned in March and it came back in April. And then in February the following year, we actually found that fish deceased up in Skookum Creek. So we've done this with many fish. We can go through a lot of different fish. We've got almost 3,000 fish captured now. The capture rate's about 22%. We're catching these same fish on the beaches in marine movements wise. And so catching these same fish off the same beach, this is just another deal. This is a fish that was tagged numerous times and out in the salt water off its beaches, and then we found it back in the marine water. So what we call this is we call this high sight fidelity, and again, what it really means is that when these fish leave the fresh water and go out into the marine environment, they will find a beach that they like for whatever reason. And you can have 10 beaches that look exactly the same, and only one of them will have a population of trout on it. And interestingly enough, generally these populations over the years are from the same stream. Now, I don't know how fish tell each other where to go to live, but it's kind of a crazy situation. But, anglers have favorite beaches they go and fish for. I have beaches that I grew up fishing, and they still have fish on them. And I have friends that say, oh, I got a beach that I can go fish, and I can always catch fish there. So that can give you a sense of a lot of fish. But what we know now, tagging-wise, either with jaw tags or pit tags or Floyd tags over this last 5.5 years, is that these are populations indeed, small populations, but anglers are actually catching the same fish over and over on that same beach. They're not transient fish that are going through like schools of salmon. They actually live on that beach. So the ramifications of that for the angling community is if you don't practice good catch and release methods, if you drag fish up on the beach, if you don't use nets to net the fish, and we lose any of those fish through hooking mortality, or simply because you fight fish and you let them go and they build up lactic acid, they're much more prone to predation from seals, from otters, from ospreys, from eagles. So this is another thing that's been published, and that paper is on the website as well, and it talks about this high sight fidelity. So it makes these fish a lot more vulnerable if they're being fished on day after day on the same beach. So this is one thing that's come up in the study that's a little bit concerning, and it's a lot concerning, really. when we take scale samples off these fish, that scale sample will actually tell us the age of the fish, and it'll tell us how many times they've spawned. And one of the things that we've seen over the last number of years is that we see fish that should have spawned numerous times have not spawned at all, or have only spawned one time. But you're going to go through this really quickly. The different colors that you can see is how many times the fish has spawned. You can see length and stuff here of different sizes of fish, how many we counted of those fish, and how many times they spawned, and the size of these fish. Of course, bigger millimeters, bigger fish that way. There was a study that was done in 87 or 89 by the department themselves, and what they found in that is fish of the same age class and physical size had spawned numerous times, where we didn't even find some of the fish as big as now as we found back then. And even the ones we did were not spawning at all, or only spawning one time. We don't have an answer for that right now, ladies and gentlemen, but it's something that's being proved out throughout Puget Sound, and this is a really big concern, and there certainly work needs to be done on it. But this is some of the science that comes out of the work that we're doing to try to ultimately determine fish per count. And the way that we can justify saying this and publishing these papers is because, scale samples are, find a scale sample here. Yeah, the scale samples right here. It's part science and it's part art. Reading to find the spawning mark on that. But in the fish, there's a bone called an otolith, and it's in the ear of the fish itself, right in here. Unfortunately, of course, we can't kill cutthroat trout because that's the only way you can get the otolith bone out. But it's a recording device within the fish that will tell us almost to the day when it was born. It'll tell us whether its mother was from the salt water or from the fresh water. It will tell us its age. It will tell us how many times it spawned. And so what we did about a year and a half ago, is we collected 50 dead cutthroat over about a 2-year period while we were walking salmon streams for salmon red counting, cutthroat red counting, or if unfortunately we lost a fish during the research work. And we sent those fish to, we took the otolith bone out, and we took scale samples out, and we sent them to the University of Oregon, and they did a study where there's a chemical called stratonium, which is deposited when they leave fresh water and go to salt water, and vice versa. And there's only 2 places in the U.S. that can do that. And that's in Oregon State and back on the East Coast. And what they found is that, yes, indeed, our scale sampling was correct. This is what you can see. This is one side of the otolith, and this is the other side of the otolith. But this is showing that they went into the fresh water and came out to salt water. And it also shows that mark here, and this is the maternal mark. So this was actually a fish that was spawned, spent time in the marine water, came back and spawned. And so this fish had a marine life mother, went to migration to sea, and there's the maternal signal, of course. Here's one without a maternal signal, and so this fish went out to sea, but it came back it was actually spawned from a mother in the freshwater. And about 20% of the fish we find now have freshwater mothers. Parasites. I'm going to kind of blast through this because I don't know how much time we have on this. This is this parasite study that we talked about. This is the parasite that we're concerned about. This is called an argulid pacifitis. This is a cocopod, normally called sea lice. The thing that's dangerous that we see right now is this is on all species of fish. They can be on cod, they can be on salmon, they can be on steelhead. This particular parasite is coastal cutthroat specific. It's not on anything else, and it's getting to be a big concern. I don't know how clear this picture is, but there's about 55 of these parasites on this particular fish. The biggest we've found so far is 111. Lots of fish now have at least 20 or 30, and this has really increased since about 2013. And we think it has something to do with water temperature, but we're not sure yet. Still an ongoing study, but this is what some of the funding helps fund as well. So this parasite thing is a concern. I'll end just part of it with what we're doing right now. People say, okay, what are you going to spend money on right now? Well, right now we're on a project called the Big Fjord Project. It's in Hood Canal. Hood Canal, of course, is the largest fjord in the United States. It has lots of freshwater streams. So what we did is the goals are to find out that we looked at 17 different watersheds in Hood Canal. So we took juvenile genetic samples out of 17 watersheds in Hood Canal, north, south, east, and west. And what we want to do is we want to find out if they're genetically distinct like they were in the South Sound. We want to find out their migration patterns. How far do they travel up and down the canal? Do they cross the canal from east and west? And by doing that same analysis, we've already taken all the freshwater samples, genetically wise, and now we're in the process of collecting marine samples. We will compare those. We will find out which streams are more productive than others, and then we will visit those streams and find out if there needs to be restoration work done in those streams. And what we've done is that this is a really unique project. It was started by the coalition to try to just determine all that, what we talked about. But this is the first time we've actually involved anglers in the science side of any of our work. And so, like I said, there's 17 watersheds and there are 7 different geographic areas in the canal. So we took samples out of the freshwater just with our own biologists. And now we're taking samples out of the salt water, and we're using the guide community to supply boats. We have the angling community in the boats, and we have a biologist in the boats as well taking the genetic samples. And so we just have ended the first quarter of sampling these 7 areas. We thought it was going to be kind of a no-brainer because we're only taking 6 fish out of each particular geographic area. January, February, pretty crummy weather months, so we really had to try to slam it in March. We ended up about 4 fish short of the goal, but we learned a lot. And so hopefully in the second quarter and third quarter and fourth quarter, we'll be a little bit more efficient. But that's the ongoing project. It's funded jointly by the Coastal Cutthroat Coalition, as well as our first-time grant from NOAA, National Oceanographic and Atmospheric Administration. We were one of 5 grantees in 2021. Over 700 people applied, and we were awarded a grant to carry out this particular project to involve the fishing community. So what we'll do is the fishing people that are involved in this will also be involved in the stream restoration work that we find that needs to be done in 2022. So that's our current project. This is what we'll do, some stream restoration. So we're going to get to questions and kind of just getting back to the last question as far as population. We still don't have an answer yet on fish per red in our study streams. We've had it at about 1.8, 1.35. We've had it at about 2.4, 2.5 males to females. But even if we end up with 2 fish per red, and one of your most productive streams only has 100 reds or 200 adult fish, then think about streams that all of you folks know. Think about streams that you maybe fish that enter into the Sound, or tiny little streams in the enter Hood Canal like Shoefly Creek or Little Shoefly Creek or Tawana Creek or Eagle Creek or Jorstead Creek. They may have populations of only 10 or 20 or maybe 30 adult fish. So when you start thinking about streams in other states that have 7,000 and 8,000 and 9,000 fish per mile that get fished on, we just don't think there right now. We don't think that we can say there are a lot of coastal cutthroat trout, and we know areas where they are there all the time, but we know now they're the same fish, and that has some ramifications. So I know it was really quick. This presentation is almost generally a couple hours long, but you can fire off any questions, however much time we have. Mark, I don't know how much time, but I've certainly appreciated the opportunity to speak with you folks, and certainly feel free to fire anything to it. I'll try to answer it as best I can.
So one question David had was, do the tribes express much interest in cutthroat?
Have the tribes?
Yeah.
So the tribes that I've talked to, certainly commercially, no. Do they take some of the bigger fish when they're seining? Especially in the canal, there are some very large cutthroat. Interestingly enough, we talk about size-wise of fish. We have yet to beach seine a 20-inch fish, and I know some of the guides have caught fish much over 20. I think the state record is 24 inches that's recorded. Personally, I've caught one 21, but that was in an estuary stream, so it doesn't count in the saltwater. But to answer that question, the tribal fishermen that I've talked with just personally have no, they admire the fish. They know it's there. In their gill nets, when they're gill netting, 99% of the fish, coastal cutthroat trout, make it through a gill net. That they're just not big enough. And unfortunately, if you're catching one in a gill net that's that large, it's really at its end of life. You hate to lose that big of a fish, but certainly genetically that fish should have spawned numerous times. But as far as the commercial aspect, no tribe that I've talked to, so I've talked with the Suquamish tribe, the Squaxin tribe, the Lummi tribe, the Stoke tribe, the Squaxin tribe. Those 5 tribes have no interest in a commercial fishery on it that they've expressed to me.
Cool. Another question was, when you were talking about the parasites, maybe some clarity on like how do those parasites affect the fish? Is it increasing mortality, or is it, they're breeding, there's just more of them, or what happens with that?
That's a great question. We get asked every time we put the presentation on the same thing. And I have to just say right now, we don't know exactly how it affects the fish. We know just in parasitic science, any parasite on any type of a host is not a healthy situation. But when these fish are caught, they swim away. We know that they really attach themselves on another presentation just on parasites. When you can see the underside of this parasite, it's frightening. It looks like something out of some kind of a scientific movie. It's certainly it's calcified biting material. Actually, it adheres itself onto the cutthroat. And we recommend people not trying to take them off, because if you do, you can actually the fish will actually react to trying to have that parasite taken off. So we don't know what they do. We know that it's probably not healthy. We know that it's increasing. And one of the things I'll just quickly touch on is when we talked about trout, coastal cutthroat trout, going into streams in the summer period when you would think they should be in the salt water, and all past science will tell you they're in the salt water. We find during walking those streams in the summer, fish that are really big fish that shouldn't necessarily not be there. And certainly when the lower South Sound heats up, they will go into freshwater streams as a thermal refuge to try to cool down. Actually, when we snorkel some of those streams, I've actually seen them lay on their side and put their gill plates right on springs to try to get as much spring water as they can to help cool down. But these parasites that are on coastal cutthroat trout exclusively cannot live in fresh water. And we've done that by taking parasites off of a cutthroat, putting them in what we call a photarium. It's a plexiglass box where you can take pictures of them, filling that with salt water, and these parasites will adhere to the side of the photarium. And bring them home, dump that out, put fresh water in there, and within a matter of minutes, they're dead. So one of the things that we think we're seeing with these large cutthroat, because we never see cutthroat in the fresh water with parasites on them, except cocopods. Cocopods is typically sea lice, but we never find argulids in the fresh water. So we think that these big fish may go into these streams as a way to unload parasites. That's speculation right now, but as far as what they do we don't have an answer of what they do. We just know that they're cutthroat specific. In Canada, they found them on a couple other species, but down here we don't find them on Atlantic salmon in the pens. We don't find them on any of the 5 Pacific salmon. We don't find them on any forage fish as well. So we just know that it's not good for them and it's increasing, but we don't know why.
Oh, not that one. I want to do this one. So follow up on that was, are these parasites more prevalent in certain or specific areas of Puget Sound?
Yeah. That's another really, really good question. And again, some of the data is a little bit skewed because we may not have anglers fishing in all the areas in Puget Sound, or if they are, they may or may not be reporting argulids. But of the anglers that report finding argulids on coastal cutthroat trout, area 10, so that Seattle area, certainly seems to be the area that has the highest concentration. So we don't know if there is a pollution component to it yet or not, but area 10 and even parts of 11 down towards Tacoma seem to be areas that have more than the rest of Puget Sound.
Cool. We had another question here. So this was, I caught a drone video of a massive school of cutthroat on Hood Canal recently, and I was blown away. It's grainy footage, yet I had no idea. Any info on this behavior? Rare or only in the springtime during chum fry?
So can you read that? Can you repeat that one just again?
Yeah, so one of the users caught a video of a massive school of cutthroat and was curious about if you notice this kind of behavior, sort of schooling, or is it during certain times of year, like when the chum fry are happening, or yeah, any info about that?
Gotcha. Okay. Yep, absolutely. So, with this, it's interesting. So in the summertime, for some reason, like I said, these fish travel there most, and and if we encounter them someplace, either hook and line wise or for randomly trying to beach a beach, we find mixed stock in that area. So I don't know the fact that they're all Oncorhynchus clarki, they're all cousins, of course, but I don't know if they're on holiday and they kind of get together. So you'll see fish kind of mass up there. But the schooling certainly takes place where they're feeding, and certainly chum fry, exodus, or pinks, when the pinks come out as well, they will certainly be in an area. But they are on a lot of those beaches in that way more times than you think they are. One just quick anecdotal story. The department was beach seining one day down in Eld Inlet at the Evergreen State Beach, which is a public beach where you can go fish. There was a gentleman there fishing. He'd been fishing for about 4 hours and pulled in the boat and said, we'd like to kind of set our nets. And he said, fine. There's nothing here. I've been fishing 4 hours, haven't had a strike. They pulled the net. The first net, I think they got like 62 fish or something. So there was definitely a population of cutthroat on that beach. They just they just didn't like what he had. But certainly, any prey fish is going to go after a forage fish, and when, if you can find schools of chum or small anchovies down in the deep South Sound, the fish will certainly congregate around there. So it's not an unusual thing to happen. But it's pretty unusual to see it. But if you're there, you're pretty lucky.
I'd love to see the video. Another question from Bao. In our fishing forums, you hear a lot about the difference in number and timing of cutthroat in the North Sound versus the South Sound. Is there any science that provides any insight in these perceived differences?
Okay, just the first part of that again about the time.
In our fishing forums, you hear a lot about the difference in the number and timing of cutthroat in the North Sound versus the South Sound.
Okay, timing of what? Timing of spawning or timing of successful fishing, or I don't know.
I think successful fishing, like people talk about like, this time's not a very good time of the year to fish for sea runs in the North Sound, or that kind of thing.
Yeah, so I think what we see behavior wise, and certainly, talking to long-time cutthroat fishermen throughout the Sound and numerous guides, there are times of the year it's better just in general. So, and again, it depends on where you're at. If you do have streams that have an out migration of chum fry, that's going to be good. That's going to be good anywhere. Interestingly enough, uh, the chum fry come out kind of in the middle of cutthroat spawning generally. So they're ultra hungry. They've gone up, they've spawned. It's tough on them. Uh, Certainly much tougher on the females, but that's just kind of a generality thing. I think is quite unfair in life. But uh, so they're really hungry. They're coming out. So that out migration time, April, May, that period of time when the chum fry are coming out, probably anywhere where you've got anadromous streams, it's gonna be fairly decent fishing. It's not going to be good fishing almost anywhere in the Sound. Now, and that, some of the guides they wouldn't not necessarily dispute this, but they are able to find fish a little bit more successfully, I think, than most of us anglers. But during the summer months, so June, July, that period, it's tough anywhere. That's when they leave their beaches and travel for whatever reason. So if you're fishing for cutthroat almost anywhere in Puget Sound during the summer, you're going to find them. You're going to if you're especially in a boat and you're running around, there's areas where you're going to find fish, and if you can find them where they kind of are ganging up and having a holiday, the much not so much the better. But certainly, you know, uh, August, September, October, November, December, those periods are generally good anywhere. I think the upper canal, I mean the upper Puget Sound area, and some of Hood Canal is just a little bit harder fishing in general than the deep South Sound. The shorelines are so much different. You got to remember these guys are stream fish by birth. They spent their first 2 years in the stream. So even when they're in the salt water, they kind of still like to hunt and fish that way. So if you have points and little corners and drop offs and little curves that the deep South Sound has all the way through, from down to Shelton, all through Olympia, Case Inlet, Carr Inlet, Bainbridge Island, all that. The shorelines are really, really convoluted, and it offers great habitat for fish. When you get up into 10 and you get into certainly the north part of almost all of Hood Canal, those areas are so linear. Those beaches don't necessarily lend themselves as well of facilitating what we see in the deep South Sound. That's not to say that you don't have beaches up north as well that people know that they can go to. I think they're just fewer. So I just personally know more folks who catch fish. I don't think it's because there are more guys fish down here or not. I just think the habitat in central and lower Sound is better for cutthroat than the North Sound, and I think we're going to be in Snohomish County within the very near future, because on the outside of Whidbey Island, hardly anything gets caught until you get down to the south end of the outside, and then the inside corner, the east side of Whidbey. And we think those fish come possibly out of streams from the mainland, and so that's an area we're going to study. But we don't know as much about the North Sound as well. But certainly beach-wise, just going up there myself and fishing with guys, just targeting beaches, we're just not anywhere near as successful.
Cool. It's good info. Another question was, do cuts have a higher thermal tolerance in freshwater than salmon in areas where they overlap?
I think he means in saltwater, but well, I think certainly when the deep South Sound and when Hood Canal really starts to warm up, like I said, that's when we start to see fish moving into streams where you would not think that they should be. And so there's certainly a thermal refuge. They don't like warm water. Now that's not to say that caught fish in water that's 70 degrees on Hood Canal, because I have. I don't necessarily target them when the water gets that hot. But I mean, we've been out fishing off the mouth of Hamma Hamma and picking up fish in the summer that cutthroat that, just randomly casting flies while we're salmon fishing. And I personally I can't tell you the water temperature tolerance between salmon and cutthroat trout. I don't personally know that.
Cool. Here's a sort of angling question. Cutthroats seem to be let me put this up. Cutthroats seem to be attracted to many European sea trout flies. Have you heard this before?
No, I haven't heard that before, but what I could say is cutthroat are attracted to just about anything that looks like they can eat. There was a study done, and I don't think it's on our website right now. I don't think it is. But I have a good friend who did his master's thesis on the diet of coastal cutthroat trout. And their diet is about as varied as a human is. So just think about, they eat sculpins, they eat shiner perch, they eat anchovy, they eat small herring, they eat sticklebacks, they eat large carpenter ants, they eat clam necks, they eat ghost shrimp. The diet is really, really varied, to say the least. So pattern-wise, anything that kind of looks edible. If you use marabou in your flies that has a lot of movement, it's really, really attractive. Anything that's bait fish wise. So certainly, Atlantic salmon flies. There's a multitude of anything that would look like a small bait fish. Again, it's not a game to them. It's a game to us. For them, they're just trying to make a living. If it looks edible, they're more than likely going to eat it. I'll never forget the time, everyone. I was fishing with one of my very close friends down in Taunton Inlet, and I've always kind of been a stickler for realistic type patterns. I tie stuff that's pretty realistic, and I was getting outfished by this good close friend of mine from kindergarten on. And I yelled to him what he was using, and he said, "I don't know what I'm using, but it's just a white fly." And I was just shocked. At that point in time, I said, "A white fly? And why would you be using a white fly?" And so he said, "Well, I bought it up in Port Angeles at Waters West Fly Shop, and they said it's really, really a good fly." Well, I mean, he caught 5 or 6 fish off that beach in his place, and I caught like one. So as soon as I got home, I called Waters West and tried to describe this fly. And so many of you people will already know what it is. It's Jeff Delia's conehead squid, and so it's a squiddy type pattern. It's made out of kind of a white crystal flash type material. Got a conehead, got a marabou tail on it. And I was just amazed. Since then, I've tied about 4 or 5 different patterns that are white, and especially in the winter, they are incredibly effective. So other times I've been out and people have been just being really successful with an olive woolly bugger. So I just really, when they're hungry, they are not specific. I can tell you though, like when the chum fry come out, they will target Bob Trigg's chum baby pattern really, really, really well, because that's what they're just tied into that. Pretty much like Pacific salmon. A lot of times when you're fishing for Pacific salmon, the size of the herring, if you're using cut plug herring, if they're feeding on tiny little 2-inch stuff, you can put 4 and 5-inch stuff out there. They won't even touch it. They're really, really size specific. I don't think cutthroat are really very, very specific. So I think any of those kind of fly patterns, as long as they have movement to them or they got a lot of shine and flash like a bait fish, you're going to be pretty successful.
And I'll just plug the fundraiser that's coming up. Both Jeffrey Delia and Bob Triggs have donated flies that they tied. So those are certainly some options for people to win. And I know Jeff, I thought Jeff was going to send us some of his Delia squids, but he sent me a dozen new flies that he's been working on with written instructions on how he fishes them, which I'm not going to share now. So the lucky winner will get those and Jeff's special instructions. So that's something to look forward to. Another question sort of about what they eat is how often do they eat worms?
Well, polychaete worms is one of their primary food sources when small fish are not around. So the polychaete worm is, if people don't know it, you can look it up. It looks like a giant centipede, got a millipede, I guess. It's got a whole bunch of legs on it. Has a couple. It spawns. When it spawns, it's kind of got a greeny body with a kind of a red dot on it. We tie a pattern up for that. It's free floating at that point in time, and you'll really see cutthroat school up when it spawns. But other times when it comes out, they're plying the bottom. As you know, they love to. They're not a deep water fish. They want to be where they can see what's on the bottom as well as what's on top of the water. Certainly in the fall, of course, you can throw stimulators, especially at high tide underneath overhanging trees and that type of stuff. If you want to cast some type of a floating stimulator or even a popper or something like that, they're not adverse from coming up on top, but they love to be on the bottom looking around that's down there for something to eat. And when polychaete worms come out, believe me, I've caught cutthroat that have disgorged almost a whole polychaete worm that I think if you unraveled it, it'd be twice as long as the fish. There's a few different patterns for that. One that you use a kind of a hollow tubing material and you inject baby oil in it. It's kind of a complicated pattern, and then it's got a hackle wound around it, and it's really, really effective. The only problem is that their teeth will it perforates the tubing and the oil goes out of it, and so you have to keep retying that fly a little bit. So I'm thinking about how to tie that with something that has the same shininess of that, but is a lot more durable. But certainly polychaete worms is something that they eat a lot of.
That's cool. I have a question for you. I feel like when we see beginners that are interested in learning to do sea run cut fishing, it's kind of overwhelming I feel like for people. And there's a lot of posts about people being like, I went out and I tried fishing for them and I couldn't find them. And I was wondering if you were to give a couple tips to people that were just starting out or wanted to try it for the first time, what would you tell them to do? And I know that's probably a really big question, but if you could give like one or two things to help them sort of narrow down where they're fishing.
Sure. So there's two really important things on fishing for cutthroat in Puget Sound, on the beach or in a boat. And if people are really interested in cutthroat and want to kind of just catch one and get enthused about it, we've got a really pretty good guide community, and some of these guys are really, really conservationists. I mean, almost every one of them has helped the coalition, is willing to help the coalition, has donated trips, and they're going to put you on fish. Now you're probably not going to get on. You're not going to be able to fish areas unless you have a boat as well, and you want to run around as much as they do. But certainly cutthroat fishing out of a boat is much, much more productive. Cutthroat fishing off a beach is a real challenge because, like, what we've been able to find is that they don't populate all beaches. Now, that's not to say that you cannot find the odd fish here or there as they're moving around. But as far as populations that are on a beach and that's where they live, and they've got pit tags in them or they've got floy tags in them, so we know that's an actual characteristic. Trying to find those beaches is really hard. And like I said, you can have multiple beaches that look the same, and why they're on one beach and why they're not on an identical beach, it's really, really hard to say. But I would look. If I didn't have a boat and I wasn't going to go out with a guide, I would certainly look for access points where you could get on the salt water. And so you're looking at state parks and county parks and that type of stuff. I would recommend Richard Stoll's new book. It's out now. It's been out for a while. It's called Sea Run Cutthroat Trout. Sea Run Cutthroat Trout by Richard Stoll. Last name is Stoll. He's a longtime fisheries scientist. He's a great fisherman. People know Richard for a long time. His book will give you patterns. It'll tell you tides. It'll give you a ton of information. But one of the things it does, it gives you locations. And Richard was telling me one time that he got an awful lot of grief after he published his book because people said, you're publicizing all these places to fish. Well, his comeback was, they're all state parks primarily. So I'm not giving anybody's secrets away. So he has a section on the North Sound. He's got a section on the Middle Sound. He's got a section on the South Sound. And so these beaches all produce cutthroat trout at different times of the year. They can be productive to a large degree, and they can be incredibly frustrating because the fish just move and they're just not around all the time. But what I would certainly do if somebody was new, I'd go to a fly shop and I'd say, I'd like to fish for cutthroat trout. What kind of patterns do I need? Is there any area that's near here? And all the fly shops will certainly guide people to where they need to go, whether it's Orvis and Bellevue, or Dave McCoy's shop in West Seattle, or Gig Harbor Fly Shop, or Puget Sound Fly Shop, or the Avid Angler, Waters West. All those folks are all great supporters, and they're happy to have people experience catching this fish. And they'll tell you where to go, but then it just takes time to go out and put the time in. Just remember a few different things. These are not a deep water fish. So if you're wading out chest high and casting another 20 or 30 feet, don't be surprised if you're not catching anything, because a lot of times the fish are behind you. So they like small water. When I approach a beach all the time, I will always cast not from the water. I'll cast from the beach itself, and I'll cast horizontally up and down the beach a number of times, and then work the fly out a ways. And I very seldom ever more than knee deep ever fishing for cutthroat trout. So don't think you have to cast a long ways, but find a beach, go to a state park. The other thing that's really important is to try to learn a particular beach. So go there at low tide and look and see what the beach looks like. Are there little depressions? Are there rocks? Are there drop-offs? And see what it looks like. And then as the tide comes in, that's going to change, and it's going to outbound as well. And so just remember also that these fish they're not like salmon that very often. So when the chum fry are doing their deal and other outbound salmonoids are doing their deal, sure, they'll gang up on and that stuff. But other times they're hiding and they're below a little drop off or a little rock or an undulation in the ground, and they're waiting for something to go by. They like moving water. They like the bait moved quite quickly. That's not to say that you won't catch fish in deep water. I've got a friend who's an incredible fisherman down here in Tacoma, guide-wise, and he fishes with clients in exclusively sinking lines in fairly deep water and really, really fast retrieves, and is really, really successful. But most of the time they're in shallow water. Find a public beach, go out, try it, look at different times of the tide, make sure you're fishing moving water.
Cool. That's great. Great info. I think we've got two more questions here. One is the largest fish that I've caught have smaller spots overall and are mostly only above the lateral line. Is there any evidence of hybrid cuts with steelhead?
Well, again, I would, if James was on the call with us, he'd probably give you a lot more of a scientific answer than that. I certainly, there certainly is hybridization between cutthroat and rainbow trout in a lot of the western rivers, like with Yellowstone cutthroat and rainbows, or with West Slope cutthroat and rainbows, and certainly to some degree some coastal cutthroat and rainbows. supposedly science-wise is if they do interbreed, then they're sterile and they can't continue to make that hybrid keep going. And spot pattern wise is that, when we're taking our marine samples, like in the Big Fjord project right now, we take genetic samples, we take scale samples, we measure those fish, and then we photograph them. And I should have paused a little bit earlier in one of the slides when we were showing different fish. They look different from stream to stream to stream. Even down in the deep South Sound, McLean Creek fish and Kennedy Creek fish look different. We were in the canal getting samples in last March, and the fish that we caught out of Tarboo Bay, which we are assuming until we do the genetics, but we're assuming they come out of Tarboo Creek. The spot pattern on those fish looked more like tiger trout than it did anything resembling a coastal cutthroat trout. The spots from basically just in front of the dorsal fin all the way to the caudal fin or the tail, almost were worm-like, like brook trout. They were amazingly different looking. So you're going to see variations in patterns. They always say that coastal cutthroat trout never have spots below the lateral line, but we've got zillions of pictures. I'm looking at Bob Stoll's book right now, and evidently that big cutthroat didn't get the message because he's got cut spots all the way down to his belly. So you're certainly going to see a variation in spot patterns.
Right. Another question about beaches, and there's sort of two questions here around the same thing, but is the common wisdom to concentrate on cobble beaches versus sandy beaches accurate?
Well, yes, absolutely. So that's not to say they aren't in sandy beaches, because they'll be on sandy beaches a lot of times with eelgrass. So if sandy beaches have eelgrass, there's a lot of stuff lives in the eelgrass, and they'll certainly cruise through around that. They'll be on kind of muddy beaches, like in the deep South Sound. There are some specific beaches that are muddy. I mean, too dangerous to walk fish type muddy, but they have an incredible population of ghost shrimp. And when they come out, these fish just gorge on them. So they will cruise around that to eat. But they also seem to leave that. But what these fish do like, they like cobble. They like oyster beds. They like stuff where there are little critters to eat, whether that's cocopods, amphipods, little shrimp, free floating crabs. All that kind of stuff is more in those kind of little rock areas, because it gives that type of lower part of the food chain places to live. So certainly, and bigger rocks as well. So not only just cobble, but if there are bigger rocks on an outgoing incoming tide, they like to hide behind that, just like they hide behind a rock in the stream. So certainly cobble beach versus sand beach. If I had to fish a beach, I would certainly fish an unknown cobble beach before I'd ever fish a supposedly productive sand beach. I personally just haven't caught all that many fish on them. Like I said, although certainly casting into a sand beach that's got eelgrass on it as the tide's coming in, especially over eelgrass, you can certainly throw into the eelgrass and see if they're cruising around in there. But they certainly seem to, when we're out beach seining and trying to find different beaches to seine to try to get more fish tagged, we're never seining a sandy type beach.
Interesting. Cool. Well, I think that's it for questions. There's a lot of people thanking you for taking time out and spending the evening chatting with us. And this was a lot of fun. And I appreciate everybody listening for putting up with the initial technical difficulties that we had.
Exactly.
But anyways, this was really cool.
Well, I really appreciate the opportunity. Everybody's financial support over the last number of years we just can't thank people enough. Like I said, our goal is to try to find out the population of this fish so that we can manage it for the long term. We just don't want it to we don't want it to go the way of steelhead and listed species of salmon. You know, it's kind of the ultimate survivor. It's been around for a long time, no matter seems what we seem to do with it. It seems to kind of keep hanging on. But I think if we manage it properly and realize the benefit that it has, you know, people talk about opportunity and catch and release, and well, why can't we kill it? You know, I grew up fishing them, and we killed them and we ate them, and I did too. And you know, in the 50s and the 60s, I did the same darn thing. But I think we're a little bit more enlightened in 2022. People will go to Wyoming, Montana, and Idaho and Oregon and not even think about killing the fish. But when I give presentations, people will say, "How come I can't, you know, catch them, keep them?" And so normally I ask them to just wait till we're done with the presentation, and when we're done, they normally come up and say, "Well, I get why we don't want to kill them anymore." So we just want to have that fish around for everybody who's listening, and for their kids and their grandkids, and on and on and on. So again, your financial support is wonderful. Please check out the Instagram site. There's stuff being put on there all the time. Go to the website if you have questions. They all come to me, so feel free to go to the website and look at the papers and more of the stuff that's going on that we've done. And we're going to be rebuilding that this year as well, so that should be exciting. And again, thanks everybody for loving this fish and helping out financially, because without you, we wouldn't be able to do any of the science that we do. So thanks so much.
Great. Thank you everyone for coming. Keep your social media eyes out for announcement for when we're going to start fundraising and when we get that started. So we've got a lot of cool stuff that companies have supported this, and I look forward to sharing it with you guys. So anyways, thanks again, Greg, and everybody have a good evening, and thanks for joining and making this a fun time.
All the best, everybody. Good fishing.
Okay. Bye.